Good morning, students, and welcome to our May 24th lesson. Today we're going to be talking about using equations to solve word problems. Our do now will be about dealing with grief, and after you finish your work, make sure you show it to me to get credit for your hard work. And we have some extra activities for you when you've finished your work today. So let's look at the do now. The do now says, this has been a year of anxiety for many students and adults. Experts say the discomfort and anxiety we feel is grief. How is this COVID based grief similar to other grief you may have experienced? And I would love you to answer that right here in your own words. I'm sure you have a lot to say about that. So let's get started. We're going to use equations today to solve word problems, and we have a three-step process that will help us along. First, we want to define the variable, and we ask some questions. What are we trying to find out? Most of the time, we will use a let statement to define our variable, and I like to use x. The second step is to set up the equation and solve it, and use those keywords, and I'll point them out as we go, to set up the equation, then solve the equation. Then when you answer it, this is where a lot of students make a mistake. You want to give exactly what the problem is asking for. So that means you need to look at the problem again. They might be asking for a certain unit or a certain time period, or a certain color of something. Think carefully about what you need to do. So let's get started with these. We're going to define the variable, set up the equation, and then solve these problems. So in our first problem is about Connor. Connor deposited $84 into his checking account. If his new balance is $451, what was his balance before the deposit? So we're going to let X equal his checking account balance. And so it says his new balance is $451. Students, when I see the word is, I often think of the word equals. So if his new balance is $451 and he deposited $84, then what we're trying to find out is the checking account balance before he deposited the $84 that he may have earned mowing lawns or doing some kind of summer help. So our problem would be 84 plus X equals $451. We'll subtract 84 from each side because we want to isolate that X, and we find that X equals 367. Let's think about what exactly the problem is asking us. What is his balance before the deposit? Well, we're talking about money here. So his balance is $367, and that's how we answer it. In number 2, we are told that 6 adult tickets to a movie at the theater cost $52.50. Find the price for one ticket. So this is what we need to find, one ticket. So we're going to let X equal each ticket cost. Now, if you're tempted to just divide this by 6, I want you to not do that. Hold off and keep yourself from doing that, because I really want you to start thinking about this algebraically. If you avoid thinking about things algebraically on the easy problems, when you get to more difficult problems, you're going to have trouble catching up. So let's think algebraically now. Now we know that a variable and a number next to each other mean multiplication. So we know that 6 times something is going to equal that total of $52.50. We don't need to write the dollar sign in our math, but we have to include the decimal. So the next thing we will do is we're going to divide both sides by 6 because we want to isolate x, and whatever we do to one side of the equation, we must do to the other. And $52.50 divided by 6 equals $8.75. So we're talking about money, so let's answer in money with a dollar sign, $8.75. Now in number 3, we are told that 3/4 of the 8th graders of Kingston Middle School went on the class trip. If 252 students went on the trip, how many 8th graders are there? So we need to define x, first of all. So we're going to let x equal the number of 8th graders because that's what we don't know and that's what they're asking us. Okay, so x will equal, let's say let x equal the number of 8th graders. So let's set up the problem. We're going to say 3/4 of the 8th graders equals 252. So 3/4 of x equals 252. Now, in order to solve this, we can multiply by the inverse. That's one way to do it, which would be 4/3. But whatever we do to one side, we need to do to the other. So 3/4 times 4/3 equals 1. We know that. I can show you that right here. So each of these cross cancel to 1. So that equals 1. So that means that we have effectively isolated our x. So all we need to do is multiply 252 by 4/3. And when we do that, we will have an answer of 336. And that means that there are 336 8th grade students in all. Remember, we're answering exactly what they asked. Number 4, after falling 23 degrees Fahrenheit, the temperature is now 51 degrees Fahrenheit. What was the starting temperature? So if the temperature fell, we're talking about subtraction. So we're going to let x equal the starting temperature, first of all. So x, and then it fell 23 degrees, minus 23 equals the current temperature, which is 51. And we don't need to use the degree sign in our calculations, but we will use it in our answer. So in order to solve this, we want to add 23 to both sides so that we can isolate that x. And our x will equal 74. And we can check this answer by substituting for x. And 74 minus 23 is 51, and our answer checks. So the starting temperature was 74 degrees. Okay, we've got a few more. It would be nice if you could try them yourself and then come back, use pencil so you can make corrections. Meanwhile, I'll move on to number 5. Mrs. Karen has 7 children in her preschool class. She would like to give each student an equal number of M&Ms. Lucky kids. If each child got 23 M&Ms, how many did she start with? Okay, so let's figure this out. We want to let X equal the number of M&Ms she started with. Because that's what we need to find out. Okay, so it says that she has 7 children in her preschool. And if each child got 23, how many did she start with? So she divided by the total, the amount that she started with, which is X. She had to divide that by 7 to get that number of 23. She started with a certain number of students and made 7 piles, 7 equal piles, groups, and each student got 23. So that should tell us how many she started out with. So if we have a denominator with X as the numerator, the easiest way to solve this kind of an algebra problem, as we've been doing in class, is to multiply by the denominator. So 7 over 7 is actually 1, so that leaves us with 1x isolated, and 23 times 7 is 161. So she started out with 161 M&Ms. And if you want to check this answer, you would substitute 161 for x, divide it by 7, and you would get 23. So in number 6, Braden scored 9 fewer points on his math test than Ava did. So Braden scored fewer, that's less. If Ava scored an 86, what was Braden's score? So she scored an 86, and if you subtract his score, you get 9. Ava minus Braden equals 9. Let's think about that. Ava minus Braden equals 9. So we're going to let X equal Braden's score. So Ava's score, they told us, is 86, minus Braden's score, which is X, should equal 9 because he ended up with 9 fewer points than Ava had. So we'll solve this by using inverse operations. So what's happening to X? Well, we have a couple things going on. We've got 86, positive 86 added to X, but we also have a negative 1. We have an invisible 1 here. So first we're going to subtract the 86 from both sides, which will give us negative X equals 77, negative 77. Now all we need to do to get this X isolated and get it to be positive is to divide by negative 1. And when we do that, we have X isolated and X equals positive 77 because negative 77 divided by negative 1 is positive 77. So Braden's score was a 77. Okay, number 7. It's about pocket folders, and we go through lots of these at school. Pocket folders are 39 cents at the store. Do you see that leading heads up 0? That tells us that this number is less than 1. Pocket folders are 39 cents each at the store. If Carolyn paid $7.02, how many did she buy? So I know you're tempted to just divide $7.02 by 39, but let's set this up as an algebra problem and let's let X equal the number of folders purchased, because that's what they're asking us. Number of folders bought or purchased, whichever word you want to use. So when we set up our problem, we know that 0.39 times x will equal 7.02. So what is happening to that x? Well, the x is being multiplied by 0.39, or 39/100ths. So let's divide by 39/100ths, which will give us 1x, and that means our x is isolated. But whatever we do to one side of the equation, we do to the other. So now our x equals 7.02 divided by 0.39, and that equals 18. You can use a calculator to help you. But what did we actually buy? Actually, I probably didn't want to put a box around that, because I want to put a box around my final answer. So we're looking at how many folders. So Carolyn bought 18 folders. And number 8, Scott takes 2/3 of his body weight. Wow. And drinks that amount of water in ounces per day. Didn't know we were supposed to drink that much water. I thought we were supposed to drink about half, but maybe he's a bodybuilder. So if he drinks 118 ounces each day, what does he weigh? So the 118 ounces represents 2/3 of his weight. So that represents 2/3 of his weight. So we want to find out how much does he weigh. So we're going to let x equal his full body weight. All right, so if he drinks 118 ounces and that 118 ounces represents 2/3 of his weight, we can say 2/3 times x, whatever his weight is, equals 118. Now, in order to solve this, we can simply multiply both sides by the inverse of 2/3, which is 3/2. And on the left side, 2/3 times 3/2 will give us 1, which isolates our x. So we have 1x equals, and on the right side, 118 multiplied by 3/2 equals 177, which makes sense. It should be more than 118 because 3/2 is greater than 1. So what does this answer represent? It represents his weight, his body weight. Now be careful, okay? He does not weigh 177 ounces. Okay, he drinks an ounce of water for every pound he weighs. So the question is, what does he weigh? He doesn't weigh 177 ounces. That would only be a handful of pounds. What he weighs is 177 pounds because he's drinking an ounce of water for every pound he weighs. So he weighs 177 pounds. Be very careful because this is a tricky question. I know you'd be very tempted to answer it in ounces, but we don't. We're going to answer this in pounds. So that's your introduction to using algebra to solve word problems. I am very proud of how hard you've all been working, and I want you to keep up the good work right up through to the end of the year. You've got less than 20 days left, and I'm sure you'll work hard for all of them. So remember, with practice, you'll be great.